Thank you very much. And good afternoon, everyone. So for my presentation today, it is data is your friend, ? So I hear you guys are going to be in charge soon, which is great. We should probably have a chat about a few things because you're about to inherit everything about this industry, the good, the bad, and the ugly. A leader to me is someone that inspires confidence with the knowledge and perspective and can make things happen. I get the opportunity to work with some of these people, and the amazing thing is they look like normal people and just walk down the street and do normal things. So keep your eye out for them. They are easy to miss. There may even be some here at this conference. So my time today for you, with you, is about raising awareness of the power of data and hopefully starting a conversation about some of the current challenges. I had planned a more data-centric discussion, but the switch to virtual required a slight change in context. In this crazy online world, I can't tell if you leave the room and call you out for it. So I need you to be present and participate for the next 30 minutes for this to work. Now, I don't like much sitting here and talking at you. Let's face it, that is boring for all of us. So the format today is to run through some scenarios and questions and then share and discuss the responses in the second half of this presentation. Ultimately, so we can build awareness of the value of data. Now, why is data important? Well, digital systems are the enablers. We need this in place to do better. We cannot improve what we aren't measuring in detail. We want to attract the best people in the industry, and this industry is critical. We need these people because we need to achieve more. And also, using data to make decisions creates positive change. As leaders in this industry, your day will come where you will soon be the one that decides whether to make positive change or just maintain the status quo. Right, now, I have sent through a link that should be appearing in your chat boxes to a type form, which we'll need to do the next section of this presentation. The link there is incorrect. So Kim, I just want confirmation that you have that, or someone. And what I'd like everyone to do is to click on that link, and then we're about to go through all the questions one by one. So I'll give everyone 30 seconds. Right, okay. Now, I'm hoping everyone's had the opportunity to join that link. So let's start with the first question. My work role is best described as, now you'll see the options come up, but the first one is process engineer metallurgist. Now, that's probably the most noble of the industry. Second of all, you have our mining engineers, and I think they get the prize for the most precise calculations based on someone else's guesswork. So we need them. The geologists among us, well, I always joke that that's just hard liquor and guesswork. Our other engineers, which is our brothers from other mothers and sisters from other misters, our business analysts and functionaries, and everyone else. We are very inclusive. So what I'd like you to do is to click the response and give everyone just a few more moments. And then we'll move to the next question. So what we want to do here is just find out who's in the audience. Right. This is always a fun question. So for scenario 2, the Australian Tax Office sends you the following letter, and you have to decide what you want to do. So it says, "Hi, insert your name. It seems that we have misplaced all your earnings data for the last financial year. So we have no way to verify how much tax you should pay us. Embarrassingly, we also cannot check your documents. Therefore, what you submit will be accepted. Would you mind letting us know how much tax you owe us and then pay it promptly? Thanks, your friends at the ATO." Now, I've provided a few options here. The first one is to review all your records in a meticulous manner and determine how much tax you owe, then submit the number and pay it. Now, option 2 is to do option A, but to give yourself a sneaky little bonus and understate your tax payable. Option 3 is to do A, but give yourself a bigger bonus as you worked really hard the last year and you understate your tax payable by a larger margin. Lastly, The other option is don't bother reviewing your records and just inform the ATO that you owe them nothing for this year. So I'll give you an opportunity to answer that one. Right. The next one, question 3. Slightly different scenario now. The Australian Tax Office sends you another letter. It says, "Hi," insert your name. "As you are aware, we have access to all your financial data, bank records, purchases, and your share portfolio. Please fill in and submit your tax return. If it doesn't match the data we already have, we will just audit you. If we identify any issues in the audit, we'll just fine you and consider incarceration. Thanks, your friends at the ATO." So this is a slightly different scenario. In the first one, we had an ATO that couldn't check anything, and now we have one that does check it with the same responses. So do you once again review your data meticulously and submit and pay that amount of tax? Do you still give yourself a sneaky little bonus? Or do you give yourself a larger bonus? Or do you not bother reviewing anything and just tell the tax department you owe them nothing? These questions will compare later the results, but this is all about governance systems. Right, something a little bit more topical now. This is the electric vehicle versus internal combustion engine question. So the question is, assuming equivalent energy supply emissions, manufacturing a long-range electric vehicle, or EV, relative to a similar size internal combustion engine vehicle generates more or less emissions. Now, here we have the option. We can choose an internal combustion engine generating 68% more emissions than an EV to manufacture, 10% more. So, option C is they are roughly the same. D is the EV generate 10% more emissions than an ICE. And the last one is the EV generates 68% more emissions than an internal combustion engine. Now, there are no right or wrong answers here. This is all about data and awareness. There's only 10 questions in total, guys. Right, this is an easy one. Hydrogen is another topical issue. Hydrogen might be the most abundant element in the universe, but does it occur naturally anywhere on Earth? So this is just a simple true or false. All right, let's go to number 6. We're almost there. Another one on hydrogen. In the context of hydrogen-powered vehicles, why is hydrogen so dangerous to store? So a lot of work has gone into this particular area. For example, making hydrogen is well understood, using it is well understood, but this large-scale storage and distribution is probably the challenge. So the options are hydrogen embrittlement, and that's where hydrogen effectively is reducing the metals or components around. Cyclic fatigue, just from the process of emptying and filling the canisters. Catastrophic failure in the event of a collision. The storage pressure, which is between 350 and 700 bar, or all of these are real issues. Okay, let's go to 7. Right, this is a photovoltaics and electrical storage question. So there is a plant that produces 35,000 tonnes per annum of nickel from a laterite and is planning to replace its 60 megawatt gas turbine with a solar power alternative. Roughly how much area would a photovoltaic farm cover to accommodate this? So I've just dropped in some numbers there. So you can see it ranges between 250,000 square meters and we got 250,000, 500,000 square meters, 900,000 square meters, 1.2 million square meters, and greater than 2 million square meters to replace a 60 megawatt gas turbine. Once again, if you don't have enough time to do the maths, we'll go through it shortly. Right, this is one of my favorite ones. Is the mining and minerals process, in your opinion, industry, digitally mature? Oh, that's the wrong one. I think I've given you the wrong question. Let's skip question 8 and go to, so the answer to question 8 is actually in question 9. Sorry, so digital transformation, data is viewed as a high value corporate asset by what fraction of people in the mining and metals industry? Now the options are 5, 10, 20, 40, 80, and 100%. We're going to have to abandon question 8, I think. Just go to question 9, and 9 match it up. Sorry, guys, we're going to have to abandon question 8. Number 9, data is viewed as a highly valuable corporate asset by what fraction of people? And the answers are 1, 5, 10, 30, 50, and 80%. So just drop one of those. Quickly there. Great. And lastly, and on a totally unrelated topic, I have a paid subscription for news. And this is a simple true or false. So if you can click on that one. Right. So what I need now is for everyone to submit their answers. And we're going to put them in the next slide. So I probably need about a minute. So Shannon, if you want to just go to full screen me, I can switch through. Now, I haven't had any questions come through, and I'm hoping that everyone was able to answer those ones. How many responses did we get? 31. Great. Okay, let's have a look at what those look like. Oh, great. There's more coming through. The more we get, the better it is. And just remember, this is all anonymous, so it's not going to be tied back to anyone. Just to check if there's any questions that have come through up until now. So what I've tried to really do is just touch on a few topical issues. And what I want to go through now is some of the detail around how we can calculate them, and also just provide you with a bit more background on some of them, in particular, why we need certain systems in place. Sounds like we'll be another 1 minute, guys. This is the problem with live data streams. Are there any questions so far from anyone? Seems I have a minute here. What are you up to? Cool. I'll share this one with you shortly. Sorry guys, I probably should have told you to grab a cup of tea if you needed one. Cool. All right, I think we're about 30 seconds out now, guys. So, oh, good one, Janine. Thank you for joining in. You've completed the quiz. I think you may have just missed the deadline on it. We'll see. My grad story. Okay, a little bit of background about me. So I actually did a Bachelor of Engineering Industrial Chemistry. at the University of New South Wales. And I actually had a bit of a weird career path. I started out in engineering. I worked at an oil refinery initially, then consulting. Then I took a little bit of a detour and joined the Defence Force. So I did that for a few years and got to fly some aircraft, which was fun. Then out of coming that, I rejoined the mining industry. And from there, I was working in process simulation and design effectively of hydrometallurgical processes. Then about 15 years ago, I actually started a company called Elemental Engineer, which was about consulting. And then about 11 years ago, I decided I was lying in bed for 8 hours doing nothing every night. So I started Metallurgical Systems, which is a software company. So that's a little bit of background about me. Thank you for that, Katrina. Right, let me share with you the results. Okay, so I'm now sharing the results. So if you can switch across, Shannon. Oh, hang on. All right. I think we should be ready to go. Let's check the results. All right, great. Thank you for your patience, everyone. Okay, so it looks like our biggest contingent is mining engineers. So thank you to our mining brothers and process engineers, metallurgists, geologists, everybody else and other engineers. So I've clearly not given a good representation of our membership here at the AusIMM. So, okay, great. That's a great view of who's here today. All right. So now let's look at this. All right. So we have a highly compliant group of people here. So to the question where the Australian Tax Office sends you a letter and has misplaced all your data and has no ability to check it, still over 72% of you will review all your documents meticulously to determine the amount of tax you pay. Now, there's 11% would probably give themselves a little sneaky bonus. 9% give you a bigger bonus, and 6%, 9% would actually not pay anything, and about 6%. So that's actually quite interesting, because what I always like to tell people is when it comes to engineering and everything, when it comes to reporting of data, engineers are just people. We always will act a certain way depending on how what systems are in place. Now, if we move to question 3, this is what we noticed. So what you can see is the level of compliance went up. So as soon as there was a governance system in place, compliance went up. And that's actually really important, because everyone starts to do the right thing. Governance systems are all about, I guess, helping people do the right thing on the basis of the company or the country. So it's good to see that we had a little bit of a shift there based on the change in operating memorandum. And the reason this is important is because if we don't have the revenue, then we can't spend it on what we need. So we'll always we'll never, we won't be able to fund the education. We won't be able to fund welfare, hospitals, defence, anything. So this is why it's really important that we have governance systems in place to make sure that compliance is high amongst our work cohort, our population, or whatever it is. And I always relate this particularly back to metallurgical accounting. So, for example, metallurgical accounting is all about reporting of the performance of the plant. Now, the problem with metallurgical accounting is there's no actual governance systems in place. There are proposed frameworks and some other bits and pieces, but there's no actual systems in place. And the thing is, if there are no systems in place, you have to expect that there will be a lower level of compliance. So this is how I would relate that back to this example. All right, the electric vehicle. Okay, so when we talk about decarbonisation, a lot of people will initially go to electric cars. And now, in my personal opinion, I think electric cars are definitely the way to go, just from a clean point of view. The issue is they don't actually decarbonise. So I'll provide you some links later, but it typically is about, for this particular example, it's about 68% more emissions for an EV than an ICE. And that's what I think 23% of us, 32% said 10%. So that's an interesting, but the reality is they generate more CO2 to produce. Now, if we don't fill them with renewable sources or non-carbon based fuels, for example, if in New South Wales, if we're topping it up with electricity, it's coming from coal. So the break-even point is, even at the 50, 60,000 kilometre mark, it's fairly significant. And that doesn't even include the recycling of the batteries or anything else, which I suspect will have to be a very big growing industry, or will even be mandated soon. So this one's just outlining that although EVs have many benefits, they don't decarbonize on their own. It's all about us ensuring that the energy supplies and the downstream processing of all this material is less emission intensive. Okay, let's go to question 5. One of my 5. Okay, hydrogen might be the most abundant element in the universe, but it does not occur naturally anywhere else. That is actually true. So it is the most abundant, and that's actually a perfect 50-50 split, which is interesting. So hydrogen is incredibly reactive. So it will form metal hydrides very easily, or it'll even reduce compounds to their sort of elemental metal forms. So it's actually very, very reactive. That's great. Okay. In the context of hydrogen-powered vehicles, why is hydrogen so dangerous? It's absolutely all of these above. So it's not saying that a lot of these can't be engineered around or haven't been. It's just that there are some real genuine challenges. For example, storage pressure is at 350 to 700 bar. You do, because you're operating at such a high pressure, the constant filling and emptying of that material does actually stress and fatigue it. Hydrogen does attack compounds. I'm sure that they're using some advanced composites that are resistant, but it is very, very reactive. So that's an important consideration. And just to go into a little bit of detail, I've just sort of got some hydrogen stats for you. So the picture you see on the right is actually the Toyota Miura, which has 2 hydrogen vessels. This is from a motor show, and you can actually see the cutout cross section. You can see that the hydrogen canister is sitting under the rear seats, which is probably the safest position for it from a collision point of view. I'm not sure if in a catastrophic failure it would be good. As you can see, we're stored between 350 and 700 bar. And if we just apply the gas law, it's about 57 grams of hydrogen per litre. Now, the interesting thing, and I guess what not a lot of people consider, is how much energy can potentially be released from something like that. So if we look at just the calorific value of hydrogen in 5 kilos of hydrogen, it's actually equivalent to 140 kilos of TNT, and it is very, very reactive. Now, that doesn't even include the energy associated with the pressure change when you have a loss of containment. So that's like an important thing to consider as a prototype. If we then look at this slide here, there are actually other technologies. And as you can see here, you can store them at much lower pressures, but each of these have their own limitations. So what you can see is there are liquid hydrogen systems. The downside is 33 Kelvin, which is a relatively cold and energy intensive temperature to keep a liquid at. And it also requires you to manage boil off. So it's not particularly efficient. Also, you have to put in a lot of energy to liquefy hydrogen gas. The other options are like a chemisorption, which is a solid state of hydrogen biochemical, that where they recombine hydrogen with a storage material. The interesting thing about these types of solid state storage is they get very hot when you fill them up. So typically you have to dissipate 100 megajoules of energy. And by heating up that much, you also have a fairly significant volumetric expansion of the storage material. Now, physics absorption process. Solid state relies on surface interactions to bind hydrogen, requires temperatures of less than 80 K. So once again, has a very low binding energy. Someone actually told me that if you put your hand on this material or near it, it will actually release hydrogen. Okay, now this is something to consider when we put things into context. And as engineers, it's up to us to put these things into context. So In New South Wales, we have 1,245 service stations. Now, let's just do the maths on the explosive energy of one of those. So if we assume that a service station can service 1,500 cars per day with 5 kilos of hydrogen and has enough stored on site for 2 business days, you can see that it has an equivalent energy release of 430 tonnes of TNT. This is a normal service station. So this sort of highlights the challenge that we need to overcome, because once again, hydrogen is very reactive. Now, to put things into context, the Beirut explosion was 600 tonnes of TNT. So it's in the same scale of destructive power, a service station and what happened in Beirut. Okay, photovoltaics. So let's look at this option here. So we're saying for a 35,000 tonne per annum plant, how much area do we actually need? So the area required let's actually go through those. So I've got the calculations for you. So most people, I think, said for about 500,000 square meters. A large percentage said 900,000. 1250 was 20%, and 11% of you saying a lot more. So let's go through some of these calcs. So let's look at 3 individual cases. The first case is an ideal case. So you can see all the maths here. 60 megawatts times 24 hours. You can see how much power we need. Assuming the panels on and clear weather days every day, we need 840,000 square meters. And that includes 100% availability. Interestingly, you work out the battery requirements too. So you need about 720 megawatts of megawatt hours worth of battery. So I just did it based on a Tesla wall. So you can see you roughly need 53,000 batteries, 53,350. Interestingly, that's over 2,000 tons of nickel and 2,000 tons of cobalt. Now, if we look at a scenario where there are 2 cloudy days in 1 week, the area quickly ramps up. So you actually need over 1 million square meters of solar panels to achieve the output. And the battery requirement also goes up significantly to 88,370, which is almost 3,500 tons of nickel and cobalt to go into it. Total energy storage is almost 2 gigawatt hours. Now, that's assuming just 2 cloudy days in 1 week. Now, let's look at the scenario where there are 7 consecutive days every 8 weeks where you're actually cloudy. The problem here is you'll need 1.2 million square meters of solar panels, but you would also need 9 gigawatt hours worth of battery storage, which works out to be about 25,000 tons of nickel or 25,000 tons of cobalt. Now, 25,000 tons of cobalt is about 18% of the world's production in 1 year. And this is just for one single plant. So I guess what we're trying to say here is it's up to us engineers to decide how to best use some of these materials. We have a very limited supply. So it's up to us to determine how we can best use that to decarbonize. And for example, given we need power to do anything, it's very difficult to have a sensible conversation about decarbonisation without talking about downstream nuclear. For example, if you have that only a limited amount of cobalt, then surely it's greater benefit in cars. But in that case, you can't use it for storage elsewhere. All right, let's go to the next one. Digital transformation. So if we go through this, the bindings process, I think question 8 was a destroyed one. Let's move past that. Let me just go through a few stats though. Challenge in the mining industry faces right now, and our sector is actually saddled with a lot of outdated systems. But you can see that we're 40% less digitally mature than other comparable industries. 25% of companies only use customized digital solutions, and the rest are just off the shelf and not very effective other solutions. There's a real gap between strategy and execution, significant gaps. And you'll also see that 72% of Australia's mining and mineral industry actually have no digital strategy or documented digital strategies. I always like this little chart here. I'm not sure if you can see it, but this is a study done by Hatch, and it outlines some of the key challenges and opportunities that our industry is facing. So, for example, if we look at that, you can see that digital innovation is really in its infancy. There's no real standardization, and there's a lot of traditional project management involved, i.e. the same rules are applied to like a big construction project as they are to digital projects. The good thing is there is an emphasis on people, and there is a genuinely positive attitude towards technology. I haven't met many technical engineers who are against digital technologies. We all want the data so we can actually use that to make decisions, because that's how we actually gain the benefit from it. And really, a lot of the barriers around adopting digital technologies are everything from cultural to, to things like we can do it ourselves. I think if those that know, I've done this presentation a few times, is I think mining companies and minerals companies have a lot of resources and a lot of talented people working for them. And they're often out on their own, figuring things out. So it's very easy for them to say, we can do that ourselves. But there's often a distinct lack of knowledge in those specific areas. And sadly, 70% of the projects actually fail. And a lot of them fail because people try to execute these internal to the organizations. And the problem is this is very disruptive to the normal business or the business as usual. So the rest of the business essentially tries to freeze or choke out the actual, the change. So it always just gets rejected. Right. Number 9, data is viewed as a high value corporate asset by what fraction of people in the mining industry? Now, I think everyone's got 80%, 30% of people think it is. So most people think it is. That's interesting. I certainly think it's an asset. But if we look at the studies done by, for example, BCG, the estimate is about 10% of people within our industry view data as a corporate asset, which is a bit of a concern because we use data to make decisions. That's what we as engineers do. We're required to, come up with technical, economical solutions to technical problems, but we need the data to be able to do that. And the thing is, there's usually no shortage of data. It's just that we typically don't use it. So as you can see here, there's a few other examples here of white papers and other research that just shows the data is growing and we're using less and less of it, and not many people value it. I think as leaders in this industry, when you inherit these projects, you're probably going to find that a lot of the digital transformation is a mismatch of solutions or capabilities or things that aren't done properly. It'll be up to you to make that decision on how you value data and how you ensure that it's used properly, ensuring that it has proper governance systems in place so that people can actually use data to make decisions and not just roll with things like company politics. All right, question 10. And I like to throw this one in, is that I have a paid subscription to news and I'm 75% say no. Oh no, that's terrible. And 25% say yes. Okay. So just on this one, and the reason I put this in here is as engineers, we're the ones that have to often work out the problems and do the maths, but we're not necessarily the communicators. So if we look at the definition of journalism, we're saying the purpose and importance of journalism is to inform society with the information they need to live their lives. Without journalism, we would be ignorant. So journalism is important because it gives us a current and relevant information about the news and public. So what I would say is one thing you could do is, if you want to stay informed, is pay for news. I find that if it's all free, then it's typically just an advertisement or clickbait, which is not going to inform you. And understanding what's going around you is important. And like I said, we need journalists to actually communicate our message. As engineers, where it's our lives are usually based on fact and black and white, and you can calculate it. But we need somebody to make that happen. And I think in the current state of the industry, it's if you don't pay your rocket scientists, all you do is end up with missile engineers. So it's important to remember that and ensure that you cover that. Right. Right. So just on closing some of this, I guess One of the things that I'd like to highlight is for leaders in our industry to be successful, you must be engaged. And that's where you'll get the most success. If you are engaged in what you are doing and in the projects that you're involved with, what you'll find is your success rate will be much higher. So I could say from a digital transformation point of view, in my experience, when a leader actually does the training and gets involved in the work and keeps everyone accountable, the results are staggering. It's staggeringly good. If leaders are not engaged, then it actually flows through to everyone else. Engineers, we're the solution people. We come up, we develop economic solutions to technical problems. That's our role. No matter what brand of engineer we are, substitute in a few words, it's all much the same thing and the same way we do things. So that's our role. And lastly, if you want to sort of make a difference, it's and you need to be able to communicate your results, is we need our journalists to communicate what we're doing and how we're going. So I guess what I'm trying to say is, if you're engaged, if you're involved technically, and you ensuring that all the other people are in place to make sure that we're communicating, then we can make positive change. And to be honest, making positive change is a lot more fun and a lot more rewarding. I guess as new leaders, you'll be the ones that get to decide what happens next. So best of luck with that. Thank you.